Twisted Builds update. I got myself a benchtop lathe. So this is a Grizzly lathe. It's a little 7 by 14 inch deal, but it is becoming super handy for the S10. What I've been using the lathe for is this right here is 5/8 ID. I think it's like 125 wall or something. Spacer material. So I got it online, had it ordered it in, and I've been cutting it with like a hacksaw, as you can kind of see here, or my this one was actually my chop saw and maybe a grinder, I can't remember. Anyway, and then I've been truing it up with the lathe, and then I've been turning it down to the exact size I need. This is going to be super bright, but I also got myself a benchtop mill. So that's also going to come handy for other, milling activities for my truck. So a little bit of work has happened to the S10. As you can probably see, those are Watts links. That's a Watts link bell crank and Watts link mounts. Yeah, I didn't take any video of me doing it originally, and it's not completely finished yet before anyone chimes in. I need to figure out cross bracing between that downright, or both those downrights across. So that way it's not a hinge point right at these corners up here, so it kind of distributes the load, because there's going to be a lot of side load on that, and that's a pretty hard 90 volt. It'll probably bend stuff up if I don't gusset it. So I'm going to gusset it probably all the way from like maybe halfway up the tube all the way to the frame on both sides. I haven't really decided yet. I got a piece of PVC pipe I'm going to start playing with to figure out how I want to gusset it. But the Watts links part is in and working, and I have tested it, and I'm going to show you how it works on video. So right now, the spacer material I was talking about was for little things like my coilovers, to space them out so that way I have clearance between the shock itself and the coilover and the axle mounting bracket. So those both sides are 1.3 inches to the thousandths or so. I had like a 3,000 tolerance between the two, machining them, which is fine for what they're doing. And then I have just the 5/8 washer, because it's a rubber bushing on the bottom, and then bolted on both sides. I also machined front spacers as well. So I've machined 4 front spacers, 2 per side. Let me see if I can get in here. There we go. So that way you got the factory leaf spring hanger, spacer, washer, heim joint, washer, spacer, and then leaf spring mount again. So those are exactly 0.390 inches. So 0.39 inches, or 390 thousandths, whatever you want to call it. And that was, I think I got them within like a, I don't know, 5 thousandths tolerance or something, 3 thousandths tolerance. That was plenty for what I'm doing. That machine, had I be actually experienced in machining, I have no doubt you can get right to the thousandths of an inch. However, I am not a machinist by trade. I have no training except for a little how-to instructional from my buddy Myron, and besides for that, I have no training whatsoever. So, someone who's actually trained, I'm sure, like Myron, he could probably get right down to the thousandths of an inch. What I'm doing here, it was plenty close enough. But there was no way for me to make nice, true, clean cuts before that were perfectly square. So this allows me to do that easily. Like, I know you could get like a bandsaw and probably get really close, but these give me 2 to the thousandths of an inch, the exact length of those spacers and stuff like that. And just other odd and end stuff, that I'm doing with the build. It'll be nice, as long with the mill, making custom odds and ends and just whatever. So, yeah. So the lathe has come in handy. I've used the mill just on test pieces. I need to get some end mills and stuff like that, but anyway, yeah, so it's coming along. The whole Watts link thing went together pretty easily. Again, Matt Mosier adjustment plate. It started out life, I think, with 14 inches of adjustment. I kicked it down to 12. The plate was too long and not where I wanted it. So which was my own fault. I designed everything. I just had him cut it out, and I found out that I was sticking my plate way too low, and things would hit because stuff was going underneath the diff, and I didn't want that to happen. So I cut a couple inches off the bottom of that. It's still giving me 12 inches of adjustment for the bell crank mount, which is the roll center on this truck. It is dead center in between the frame rails. Again, mounted on 1.5 inch tubing. This is, I think, 1.25 inch DOM or something like that. And the tubes are the same way. They're the same pipe as the downriggers, or the down pipes. And then I'll have, again, I'm going to do DOM cross tubes on both sides to help with handling the load into the chassis. So, WattsLink. This is the roll center of this bell crank setup. So this guy right here is the center bolt. There's two 5/8 bearings inside this tube. These bell crank plates are actually my design. I designed them up on Fusion 360 and had Matt Mosier cut them out. 5/8 holes for 5/8 rod ends and everything. Same kind of stuff I'm using for the control arms. Not as beefy because there's not as much load on this stuff. 5/8 bolts, 5/8 bolt through the middle. Again, that for the geometry lesson, if you don't know anything about a WattsLink, that is the roll center. So having this adjustment plate right here up and down, I don't know if you can see all the way up. Yeah, here I can see all the way up because the frame's right there. But this right here will allow me to take that roll center and move it up. I believe it's in 1 inch increments, all the way up to the top. That way, and I have already actually tried it at the top, and it will still clear the bed and everything else, still clears the top of the frame, and it will allow me a full foot of roll center adjustment, so that way I can adjust how the truck handles. Roll center, or how the WattsLink works, is pretty much definitely when it's chassis mounted. Again, center bolt doesn't move, this setup doesn't move, tubes move around, bell crank moves around. Let me just pick up a side so I can show you. So pick up the side right here, and you can see how the bell crank moves. Not a lot, and the axle, obviously moves because I'm picking up on one side of it, but the axle does not move left to right throughout its full travel. So the center of this axle stays in the center of all this. And you can see that's kind of a worry I do have, is hitting frame right there. But I did check. This shock should bottom out before this hits frame, and I still need to put a bump stop in here, so I should be good to go. The bump stop should get it below the shock's complete travel, so I should be good to go. But, and that's like, if I had to do it over again, this mount would probably get changed a little bit. This is a 6-inch bell crank, so it's 6 inches from here to here. I'd probably drop that down to 5 inch. And then this could come down a 1/2 inch because it's a 1/2 inch on each side. That side would go 1/2 inch up. This side would go 1/2 inch down, and that would give me another 1/2 inch of clearance on top of here. But for what it is, it's gonna work pretty good. I shouldn't hit frame. If I do, I'll address it later. But it's the one thing I am kind of concerned about, but I'm not gonna know until I start driving it. But yes, so that's how that works. And you saw how it moves left to right, like this bell crank moves left to right. And it does the same thing no matter where you have it adjusted. Once you get started higher up, you have to turn these out a little bit to get it where you want it. But for instance, like left and right adjustment, now this is just to be quick and dirty. You technically need a tape measure to do this right. But say I want to move the rear axle. This right here, making this bar smaller in length, because I'm twisting it in, is pushing that axle out. So the whole axle is going that direction right now. And if I undo this, it's pulling the whole axle this direction. So it's coming towards me now. To do it correctly, you should have a tape measure on both bars, because both bars need to be close to parallel or close to the same length. Doesn't have to be exactly, so just because you don't want any bind going up and down the suspension. So to do it correctly, like whenever I do my final setup, I'll get the tape measure out and get the rear axle centered perfectly along the frame, and then get the bars set correctly, and then it'll be just a back and forth adjustment between the two for a little bit so you get it dialed in. So side to side adjustment is a little picky on these, but you can move that whole rear axle left to right pretty far, and keep the geometry correct on your belt crank as well. And again, I can go all the way up to here, and yeah, the belt crank moves over a little bit, but it still works. I've checked it a few different times. The rear axle still stays centered throughout the travel. But that's the genius of the belt crank. So you'll see, or the Wattslink setup. So you'll see there have been few that mount their belt crank right onto the diff cover. That keeps the roll center high or low compared to the tire contact patch. Thing is when your suspension is moving around and doing stuff, your roll center changes in relation to the center of gravity of the vehicle. Center of gravity of the vehicle, think of it like a 3/8 or a 1/2 inch ratchet. Your hand is on the handle. Think of your hand as the center of gravity. Think of the socket as the roll center. So the center of gravity is the weight when you're going around a corner, applying load against the body left or right. So the genius thing about these is if you chassis mount your belt crank, you can keep the roll center in same relation to your center of gravity no matter what that axle is doing. The axle can be flopping all around, going over bumps, whatever. Your roll center stays in the same relation to the center of gravity of the vehicle. And that also means if you have this kind of adjustment, say my center of gravity is like this, third hole down from the top. I could put that belt crank right at the center of gravity, and then in theory, it's like putting your hand right on the socket itself. So your center of gravity doesn't have a lot of torque ability over like a body roll on the rear of the axle. So in theory, I shouldn't have to run a sway bar with this setup. I should be able to move the roll center up high enough to where I can still get traction, but eliminate rear body roll. And that will also allow the rear of the vehicle to go over bumps and keep the tires on the ground as long as physically possible, because of the fact you want to put power down, and a sway bar makes it more act like a dependent suspension, where if like this one goes down or up, it's going to try to make the other side as well. It just doesn't work as efficiently. So that's the running theory. I'm sure someone probably brighter than me is going to come in and chime in with things. That's fine. I would love to learn. So please comment in the comments if you think I'm wrong. But everything I have talked to people and everything I have read so far, that is how it works. And that's how I'm rolling with this suspension. So yeah. So next thing up is going to be, as I said, I've got some PVC pipe, and I'm going to just kind of test fit bars where I want to put a bar on both sides to make sure it clears these bars. I guess the support bar to make sure it clears these Wattslink bars. And then once that's done, and like the actual bars are welded in, it should be putting this thing on. I gotta get the rear axle seals in, put axles back in, rotors, wheels. For now, I'll do calipers later, just to get it back on wheels and tires and on its own weight again, because I haven't seen that in forever. So I want to do that. And then it's probably going to get pushed out of the truck, or out of the garage, turned around, brought back in, nose out, instead of rear axle towards the out, and start in on the front suspension, which is going to become a chore, it looks like. So we're going to find out. But I'm getting really, really close to having the rear done. So it should be just those braces and setting. I got set up the initial toe and set up the initial toe, set up the center of the axle, and then just tighten everything down, get everything kosher. I'm probably going to set the coil springs up on the 4th hole adjustment in, which is a little less than halfway. For initial setup, and the Wattslink is probably going to come up a little bit in the belt crank mounting position. But yeah, that's about it. So I guess that's the end of this S10 build update. The links to go through the test. Jack is at full height. There's like I don't know, probably 1.5 2 feet or so, probably 1.5 or so underneath air underneath that tire. That tire's off the ground, and I've been not hammering, but pressing on this corner right here to get this tire to hit the ground to find the other one, which is picking up the driver's front tire, by the way. And found out that I did verify that shock bottoms out before the frame hits my my mount for my Wattslink. So success. It's amazing what geometry and a little bit of math and measuring will verify, but I thought it was okay, but I just wasn't sure. And sure enough, real life matches what I was seeing on the computer or on paper. So there we go. Next time I come back, hopefully this is all done and I start working on the front. So thank you guys for watching. If you like these videos, please subscribe. If I mentioned anything wrong in your opinion or your knowledge of this, let me know. And hey, thanks for watching. Have a great day. Bye.